Greeting guys, so welcome back. So in this video we'll be seeing GitHub action for machine learning, and it's a completely beginner tutorial and where we'll be learning how to automate machine learning training and evolution using Scikit-learn, GitHub actions and CML. Let's dive in. To precise, one of our subscriber requested for this video. Before jumping, if you are passionate about AI and machine learning, I have got something special for you. Simply scan the QR code on the screen to head over to my website where you can subscribe to my free newsletters for AI and ML blogs. Once you are on the site, don't forget to sign up for the newsletters. You will get notified on everything from beginner guide to advanced AI techniques. And if you love in-depth articles, make sure to subscribe to my Substack AI magazine, where I share detailed insights, case studies, and thought pieces in weekly and monthly basis. So why are you waiting? Just scan the code, join the community, let's learn and grow together. So in this part 1 tutorial on GitHub action for machine learning, we'll be only seeing how to train the model and how to compute the results that we obtained from the model locally in the VS Code. In our part 2 tutorial, we'll be seeing how to just create this training pipeline with our CICD using GitHub action. So in the fast evolving landscape of machine learning, the ability to rapidly develop, test and deploy model is crucial for success. So GitHub Actions and Continuous Machine Learning CML, which is empower data scientist and machine learning engineer to automate their workflows, streamline the collaboration and enhance the productivity. So what is GitHub Actions? It's an automation tool that enables developers to create workflows directly in their GitHub repositories. By integrating continuous integration and continuous development CICD practices, GitHub Actions allows teams to automate their software development process from building and testing code to deploying applications and managing the releases. So with just a few lines of YML configurations, users can set up complex workflows that respond to various triggers such as code commits, pull requests, and issue updates. So this not only increases the efficiency but also fosters a culture of collaboration, ensuring that team members can focus on what they do best, creating impactful solutions. Now, what is CML? Continuous Machine Learning, which is it takes the principles of continuous integration and applies them to machine learning projects. It allows data scientists to track and manage their experiments seamlessly while integrating with version control systems like GitHub. So with CML, you can automate the entire lifecycle of machine learning workflows from data pre-processing and model training to evaluation and reporting. So by creating dynamic reports that include key metrics and visualization, CML ensures that all stakeholders have access to crucial insights and can make data-driven decisions with ease. So this transparency promotes accountability and encourages experimentations, leading to better models and improved outcomes. So when combined, GitHub Actions and CML provides a robust framework for managing machine learning projects. By automating the training and evaluation process, teams can ensure consistent results and rapid iterations on their models. The integration of CML within GitHub Actions allows for seamless reporting and collaboration, making it easier to share insights and results with team members or stakeholders. So in this tutorial, we demonstrate how to harness the power of GitHub Actions and CML to build an end-to-end machine learning pipeline for churn predictions. By following this approach, team can elevate their machine learning projects, reduce time to market, and ultimately drive greater business values. So to learn more on GitHub Actions, here's the documentation page. I will provide the link to this documentation in the description below. You can just have a look on it once after this tutorial. So, and then we have CML documentation as well. I will provide the link as well in the description. So once after this tutorial, if you want to learn more on these topics, so do not hesitate to click the link in the description below and learn further to enhance your knowledge on it. And as well, here is the GitHub repository regarding the CML and how we can set up CML. So as I said, for this walkthrough, we will be creating a repository for the first time. Let me name the repository for our project, which is GitHub action for ML. So I will be making this repository as public, and then we will be adding the README file, and the gitignore file format will be for Python language. And then in terms of license, it's open source MIT, and then let me create the repository. So now our repository have been created. So once after that, we have to clone this repository in our local machine. For to do that, we have to copy the web URL, and then we have to go to terminal. So we have to open the terminal in the directory where we want to clone the repository. For that, I will be cloning this inside my tutorial, and then for to do that, so we have to open the command line with the directory where we want to clone. So let me list. We will be cloning this inside tutorial. So for to do that, I will go enter this repository. Yeah, it's done now. So for to clone, git clone, and I have to copy paste the web URL that we have copied from here. So once we are done with the cloning, we have to open the project in the VS Code. For to do that, let me open the VS Code here. So now we have to go open. So inside our documents, we have GitHub and then tutorial. So from here, we'll be having GitHub action for ML. This is the clone repository with the predefined files like license and README file. Let me open this. So we have a gitignore file for Python project as well inside. For this ML machine learning project, we will be using dataset. Okay, so let's see about which dataset that we're gonna use, and then we will be just downloading this dataset inside our GitHub file. Okay, and then we will be creating our requirement.txt as well to install all the necessary libraries which are needed for our project. So let me start with the dataset. Okay, so we'll be using Churn dataset from Kaggle. Here is I will provide the link to this dataset in the description below. So basically, if you see this dataset contains details of bank customers, and the target variable is a binary variable reflecting the fact whether the customer left the bank or closed their account or they continue to be a customer in the bank. So we have a set of columns like row number, customer ID, and then a name, and then credit score, geography, gender, age, tenure, and then balance and number of products. And there are other columns which aren't added here in the CSV. So we have the binary flag which reflects the customer closed their account with the bank, and 0 if the customer is returned. 1 is for the customer we have who have closed the account already. So this is all of the data set that we're going to use for our modeling purpose. So we have to download this data set. Let me download. For to download the data set, you have to log into your Kaggle account using maybe your Google account. Okay, so let me go here. So let me move this to the project directory. So it's done now. So we can find the CSV file here. Let me install the Rainbow CSV environment. So let's visualize. So as we saw in the Kaggle, we have a set of columns which are available in this dataset. So once we have our dataset downloaded, we have to create our requirement.txt. For that, let me create another file, requirements.txt, to like add all the libraries that we need for this project. I have set of libraries already in my hand. So these are the libraries that we need. Of course, we need a scikit-learn to train the model for this churn predictions. And then for visualization, we need matplotlib and other libraries that we need in order to do the pre-processing and then saving the model. So for to like install all these libraries, we have to do pip install requirement.txt. These libraries are already installed in my current environment, which is in my base environment already. So from your side, when you will be testing this in your local machine, do not hesitate to run pip install requirement.txt in order to make sure that every packages that are needed for this projects are installed. So now we have to prepare our train file. Okay, so for to do that, let me create a Python file, which is we will be naming it as train. So first we have to start with importing the necessary libraries. Just import all the libraries that we need. Okay, so once it's done, we have to initialize the class, which is churn model pipeline, which will be holding the main functions like load and prepare more data, and then build the preprocessor, and then we will be building the model pipeline. Then we'll be having the function to train the model, and then the function to evaluate the model, and then we will be plotting the confusion matrix, and then we will be saving the matrix in text file, and then we will be plotting ROC curve, and then we will be saving the pipeline, and then we'll write our main function to call all these predefined functions in our churn model pipeline to train the model. To pre-process our data, and then to train the model, and then generate the report and save the results in the PNG format. Okay, so let's start creating the class. Okay, so first we have to create the churn class and then init function. So we'll be initializing this class with a few parameters: data path to the dataset, and then target column, name of the target variable that we will be using for to predict, and then index column. So an optional parameter which will be specifying which column should be used as an index. So currently we will be putting this as none, and then we'll be just having a random state. For example, I put like 1 to 5 for random state. Once we're done with it, we have to initialize set of parameters. So basically, this is a constructor method that initializes the attributes of the churn pipeline class, and it setups like initial configuration needed for like data pre-processing and model training. So let me write the code. Data path, just data path here, target column, and then we'll be initializing several other attributes like model pipeline. This will hold the complete pipeline for pre-processing and modeling. And then our X train, X test, and then Y train, Y test, the placeholder for like training and test dataset. Currently, we will be initializing all as none. We will be populating this variable inside our pipeline later. And then our preprocessor. This will hold the pre-processing pipeline. Currently, we will be assigning this as none, and we will be populating this in our pipeline. So once we finish with this constructor method, we will be writing our load and prepare data method. So basically for this method, loads the data set from the specified path and then pre-process it by shuffling and splitting into features and target variables, and then it divides it into like training and test sets. So let's write the function. So here we have three parameters. Let me explain one by one. So drop columns, it's a list of columns that we're gonna drop from the data set, and end row is the number of rows to read from the data set. So we'll be basically using pandas to load the data frame. So let's start the loading data process. So with this simple message. So we'll be reading the data set from pandas. So where we'll be using a data path, and then we'll be initializing index column as self does index column, and then we'll be providing all this detail once we will be calling this method, okay, in our main end rows. So once we're done with it, we have to drop the specified columns to clean the data set. For to do that, we'll be checking if drop column is given or not. So if drop column is given, so if we have these columns which are provided in the drop columns list, we have to drop it. For to do that, we will be doing df.drop columns, as we will be just deleting only the columns. Okay, so once we're done with it, we have to sample our data. It means we have to shuffle the data randomly to ensure that the training and test sets are representative. For to do that, we can use df.shuffle sample method with a fraction of 1. And once we're done with it, we have to separate the features x and the target variables y. So for to do the x, we have to do df.drop. We'll be using all the columns except the target columns. Okay, for to do that, cf.drop and then self, we will be getting our target columns from it. And for to get y, we can just get target column using self.target column. And now we have to use a train test split to divide the data into training and test set. So for training, we'll be having like 70% of our data set, and then for testing, we'll be holding out 30% and ensuring the randomness by using the random state. So let's write the code for it. So we have to split like xtrain, as we have already let me go here, let me correct the name of this variable. So we'll be having our xtrain and then xtest, ytrain, ytest. Now we'll be calling train test split from scikit to split the data set. As an input, we have to give our x and y variable, columns, and our test size would be like 30%, which is 0.3, and our random state will be the random state which will be provided while calling this load and prepare for data function. So this will help us to just produce the same test train split every time when we will be using the same random state. Okay, so we have now done with our load and prepare data set function. So let me just give the log message. Great, let me zoom in a bit, okay, to make it more visible. I think it's better now. Yeah, now it's time to write our build preprocessor function. So basically this constructs a preprocessing pipeline to handle like both numerical and categorical features. So this is crucial for like preparing the dataset for machine learning algorithms or like machine learning projects. So let's try to write this function now. So as I said, we'll be preprocessing our categorical columns and even the numerical columns. Let me get the numerical and categorical columns. So here we'll be printing preprocessing pipeline. So if you see here the categorical columns, which is a list of indices or names of the categorical columns, and some column is a list of indices or names of the numerical columns. So now we will be creating a separate pre-processing pipeline for numerical and categorical feature. For example, for numerical transformer, we will be trying to impute the missing values using the mean, simple imputer, and then we will be scaling the values using standard scalar for better model performance. So let's write this numerical transformer pipeline. So we'll be using simple imputer from Scikit, and the strategy to fill the missing values would be mean, and we'll be using the scalar function to scale, which will be the standard scalar. Yes, so now we will be going for categorical transformer. So where we will be inputting the missing values using the most frequent values, and then we will be encodes these categorical variables as integers using ordinal encoders. So let's try to write this categorical transformer. So let's define the imputers for this, the same as simple imputers, but now the strategy is most frequent, as this is a categorical column. And then we have to define the encoder method. It's ordinal encoder. So this is a basic transformation that we used to do for all the machine learning projects. As we combine these transformers into a single column transformers that applies the appropriate pipeline steps to respective columns. So the next will be the processor. Now we will be calling the column transformer, where we will be adding the transformers that we have defined earlier. So transformers, we have the list of transformer is for numerical columns. So another one is for categorical cat columns. Okay, and we have the remainder as pass through. So we're now done with this pre-processing pipeline. Let me print the log message as well. So now it's time to build our model pipeline. So where we will be constructing the main model pipeline, which includes like feature selection and the machine learning model itself. Okay, let's write this function. I have added the k best values as we will be doing to get the best parameters used with the model training. So basically it's hyperparameter optimization. So now we are in the phase of building model pipeline. Let me log this message. So now we have to initialize the feature selector using a select from model with logistic regressions, and then which helps in identifying the most important features. For to write this feature selector, select from model from Scikit, we'll be using logistic regression model with a maximum iteration. Example, let's give 1000 for now. We can test with more iteration as well. Okay, now we're done with it. So now we have to do define the main models as a gradient boosting classifier, a robust ensemble learning algorithm. So to load this gradient boosting classifier class, we will be having few parameters like n estimators, random state for the reproducibility of the same result every time we use to train this model. So let me assign random state that will be given while calling this. It will be given while constructing the model pipeline. So once we're done with it, we have to combine the feature selection step and the model training step into a single pipeline. So this means when the model is trained, it will be automatically select the best feature based on their importance. For to do this, we have to get our train pipeline, where in our pipeline we will be combining these steps like feature selection. So the feature selection, and the next step would be the feature selection. We have to assign the feature selection as well in tuple, and then we will be having our gradient boosting model. So here we will be using the model from here. So our training pipeline is ready. Now we have to combine, as our model pipeline would be pipeline, where we will be combining the preprocessor and the training pipeline. Here the steps are preprocessor that we have already did here. So let me name it as preprocessor. We'll be getting the preprocessor. Let me add the training step as well. So name it as train, and then let's load the train pipeline. So far we have built our model pipeline. We log the message as model pipeline built. So the next method that we need is like training model, so which will be trains the complete model pipeline using the training data set. So let's define this model function train model. So let's check model pipeline is available or not. For example, if self.model pipeline is none, if it's none, we have to raise and value error. Just a simple log message that could help us to understand like whether our pipeline have already built on, and then we will be printing the message. If it's not none, of course we will be continue with the training process. So if it's not none, we will be giving the log message as training the model started. Okay, now we have to fit our model like it can be done with model pipeline fit, where we'll be giving the input as the input train and then the target variable. So once the fitting complete, we can print the log message as model training completed. So basically if you see like it just checks if the model pipeline is built, and if not, it will raise a value error, and then it will fit the model pipeline on the training data, and then during this process the pre-processing steps are applied, and then model is trained on the transformed data. Let's write our evaluate function. So to evaluate our train model, so for to do that we'll be defining a new method like which is evaluate method, model. Here we'll be having a log message saying evaluating the model. So now predict the labels for the test set using the train model. So and then calculate the accuracy and F1 score matrices using accuracy score and then F1 score from Scikit matrix. So it may provide the ground truth and the predictions that we got from our earlier line. Let me compute F1 score as well. In the same way, we can provide the average method that we want to use, which is macro, for example. Now print the accuracy and F1 score to the console for immediate feedback. So let me do like round the accuracy and multiply it with 100 decimal point, and then we have to do the same for F1 score, and then we will be returning the accuracy and F1 score from the evaluate function. So now as it's a classification, binary classification problem, we can even plot the confusion matrix as well. Okay, so we have to generate and save a confusion matrix to visualize the performance of the classification model. So this model will be uses the model to predict the labels for the test data set, and then it will be computing the confusion matrix, comparing the actual labels with the predicted labels. Let's write the function. As always, let's start by printing the log. So we can import the confusion matrix with the ground truth and the predictions, and as well we have to provide the class labels. So we can get this by from model pipeline dot classes. So now we have to use this confusion matrix display to like create a visual representation of the confusion matrix. For that, let's use the confusion matrix display class. The input will be confusion matrix, which is CM in our case, and then display labels, model pipeline classes, and this dot plot will help us to visualize. Then again we have to save the plot as an image file using model result.png, for example, for later use. In our case it will be used in the reports in using CML. We will be seeing this later in the tutorial. Okay, let's print another log message once we done with confusion matrix saving process. Great, we have just built a class to plot the confusion matrix. Now it's time to save the matrices. So we have to save the matrices in text file. I will let you know why we are just saving these matrices in table, and it will be really helpful with CML while generating the report in our CICD pipeline. So the purpose is to save the evaluation metrics like accuracy and FN score to a text file for documentation or report later. So let's write this function, save metrics. We will be saving it in a text file, for example metrics.txt. We're going to be writing this file. So consider this as an output file. Now we have to write the out file dot write, and we will be providing the accuracy equal to, we will be rounding the decimal point. We should use formatting like this. So you have to do the same for the FN score as well. So now let me give, so I have to add the new line. It's out file, for example, because we are opening the text file as out file. Yeah. So now print matrix is saved in matrix.txt. Okay, single quote here as well here, as it's a file name. So now our last step is like we have to save the pipeline. Okay, for to do that, save we will be doing save model, save pipeline method, which will serialize the trained machine learning pipeline and saves it to a file for the future use or deployment. So save pipeline, saving pipeline to file to save this pipeline, and our pipeline is in the model pipeline variable. We'll be saving this pipeline with the name Churn pipeline with SKOps format. So now we have to print the log message saying pipeline saved as churn prediction SKOps. So let me put this in a single quote to know which is the name of the file. So now we have the set of functions which are ready for to train our model. The first thing that we have to do is we have to create our main function to call all these methods one by one. To do that, let me write. So let's define the configuration for loading data, specifying target columns and then columns to drop, and then categorical and numerical feature indices. As we saw, these are the variables that we used and to initialize the churn model pipeline. So we had to configure this in our main function for the first time. So let's do it. So we are in the configuration phase. Let's name the data file. So in our case, it's churn modeling.csv. So now our target variable, as we saw earlier from Kaggle, it's excited with a boolean value whether the customer retained account in the bank or they have left the bank. So this one, the last column. And then we have to drop some columns which aren't useful for us or which aren't add values the performance of the model. So in our case, we have some of the columns like row number and then customer ID, sorry here, and then even the name, which won't play an important role in determining whether the customer will go out or will stay. So let me as well done it. So we done with it. Now we have to identify what are the categorical columns which are in our data set. So we have to give the indices of this column. For example, in our case, let me go here. Yeah, geography, gender. These are the categorical column. You can see here from here. Once after dropping these three columns, the index for the geography and the gender would be 1 and 2. So indices after dropping, now we have to give the numerical column indices. Okay, so except these two columns, all the other columns that we saw here are like numerical columns. Okay, so let me write 0, sorry, not 1, 2, but 3, 4, 5, 6th column, 7th column, 8 and 9. So totally we have like 9. Okay, so it's done now. Now we have to initialize the build pipeline. So now for that we have to instantiate the churn model pipeline class. Let me write a simple command as well. So now we have to load the, which will prepare the data where it need two variables, which is drop columns, where we have already defined our drop columns here in the configuration, and then our end rows to keep. For example, we will be keeping only 1000 rows, and then we will be doing churn pipeline dot build preprocessor. It need two column list. One is categorical columns, another one is numerical columns, or to like build the transformation pipeline. Okay, and then we will be calling build model pipeline. So once it's done, we have to train and evaluate. For that, we'll be loading churn pipeline train model, and we'll be evaluating the model and getting the matrices, which is churn pipeline dot evaluate model function. So once it's done, we have to plot our confusion matrix and save the matrices in text file. So these are just the functions that we have predefined earlier with the churn model pipeline class. Sorry. So let's save the matrices as well with accuracy and FN score that we got from our evaluate model. So once it's done, we have to save the pipeline. To save the pipeline using this method. Okay, basically this is our pipeline. For the first time, we have our init function. This helps us to set up the initial state of the churn model pipeline, and it defines the essential parameters such as like path to the dataset, the target variables, what that we want to predict, in our case, which is the binary variable, and the random state for reproducibility. And we'll be having our load prepare data function, which will be help us to load the data set, shuffle it, and then splits it into features. Those are the inputs that we will be feeding to the model, and then the target, which is the output from the model. So it also divides the data into like training and testing set. And then we'll be having our build preprocessor function, which constructs a data preprocessing pipeline for handling numerical and categorical columns separately. And we'll be having our build model pipeline, so which is used to set up the full machine learning pipeline that includes like feature selection and then model training. And we'll be having our train model function. So this fits the model to the training data, and then we'll be having evaluate model, test the trained model on the test sets, and then calculates the key performance matrices. And again, we'll be having our plot confusion matrix function, which will visualizes the model performance through a confusion matrix, which shows the counts of true and the predicted classifications. And then finally, we'll be having our save matrices, which will save the evaluation matrices like accuracy and FN score to your text file. And then we will be having our save pipeline function, which will save the entire trained model pipeline for future use or deployment. And we have just like main block, which will be run when the script is executed directly. So it ties together all the components of the class that we have initialized earlier. And then we'll be testing this train file to see how it outputs the results. Okay, for each method I have added the docstring. So now we are ready to like run the pipeline. So to do that, let me do python train dot. Great. So for the first time, it just load the data and then split the data successfully, and then building the processing pipeline is complete. And then it just did the model pipeline build and then model training and then evaluate the model. Like it just gives the accuracy of 80% and F1 score is 63. Still, I agree that we need to improve this model, but basically we aren't using the whole data for the model training. We'll be using a sample of data for the training. So it's, I think, we have to use the whole data, and as well we have to do some other hyperparameter optimization, and then we have to test with other classifier models as well to improve the model, to see whether data is more representative to help the model to generalize well. And then it just say the confusion matrix in the model result, and then matrices in the matrix file, and then pipeline in the SQOps. Let's visualize and see the confusion matrix. Okay, you just done a good job. Like if you see, we are at the end of our part 1 tutorial on GitHub action for machine learning. So in our part 2 video, we'll be seeing in detail about the confusion matrix result and then FN score accuracy that we got from our model. And also we'll be seeing how to integrate CICD pipeline for this project using GitHub action and CML. I will try to provide the link to the part 2 tutorial in our description below. I will also provide the resources that we used in this tutorial in the description below. If you like this video, do not forget to give it a thumbs up and do not forget to subscribe to our channel. In the way you will get notified whenever I upload a new tutorial or video. Until then, this is Avonia. Bye for now. Thanks.